I thought I'd get this video before I get too far into my testing. I've got the revised fan is in place with, and I've also got a heat sink on each one of the transistors. So I've added the heat sink and I've got the final design, but it's a pre-production fan, meaning there's some things I had to do after the print and assembly to make it right, but it's a production design. It's going to be production design. From what I could tell, the sensors are all in the same location. No, this sensor's moved, okay? Let's get it back. There, that's where it should be. Okay, and that's going to cause a change in the reading. I'm going to let it settle down for a minute. I can't move these wires a whole lot because that'll affect their position. You might notice there's some warping going on here, so I'm going to have to stiffen this plate up. But as you can see, just moving that about created a difference, 106 to 83. So let's put that down. It's at 345. I've got an 84 and a 10, now 106 with 3 volts. So the sensor was not in the right location, or at least in the same location as it was. The machine is running at, this is a different transformer. This is a 15B. It doesn't go to 100, it goes to 120. So I went out at 100, it's at 100%, which I call 120 miles an hour, but it's 100% of the transformer. It's still around 15 volts. And as you can see, we got 90 and 109, so it's climbing 109, and that's at the end of 345, so we'll call it 346. I'll wait till I get to 346 and I'll key the number in exactly as it is. Bingo. 346 is at 93, getting hot. 11, getting hot. 3 volts on the fan. So it would appear, while there may be some improvement, it's not arms and legs improvement. And I'm running this fan at 3 volts. At 3 volts, it's supposed to be giving me something like 10,000 RPM. I mean, it is a screamer. It's just one that I found, I bought, and I sent it. I got 4 of them, so I use it. It gives me the high speed. I thought it would help. Now we're up to 114. At 120, I'm going to shut everything down and take notes on what we have. But, so it looks like I'm burning up my motor or something. It looks like we're getting overheated somewhere. Oh, it's warm. Everything's warm. I'm going to turn that off. I'll just stop it here. When the engine's slowing down, a couple of things. The armatures can be getting hot. The brushes could be getting hot. The PC board's getting hot. It's hard to say. Let's see what we got here at 347. At this point, we got 105. Oh, my God. That's when I shut it down. The fan quit, see? So the fan was carrying some heat. This has cooled off a little bit. This one went up when I shut it down. This one went down. So there's some differential. And now what you can see is, oh, this one's moved even. This one is actually inside the chip, you might say. It's inside the heat sink. So it was really reading maximum. This one is sort of outside on top of the board, which is what I wanted, but it's very close to touching this heat sink. So it's almost heat sink touching too. Oh boy. Okay, so my sensors moved around on me. It gave me some goofy readings, possibly. Let's see if I can pull this out one-handed. Probably not. I can feel it. It's warm. Everything's warm. Okay, I got it. This is the assembly. It's plugged in. I can unplug it. I should be able to. I don't know if I can unplug it with one hand, but there we go. So it's unplugged, and there it is. I put a trim pot in here because I only have 12 volts, and I had no way to regulate it, so I just put in a resistor. Probably not the smartest thing to do because that really loads everybody up. Didn't warp it. But anyway, I was feeding this 3 volts with that trim pot. There's other ways to do it, better ways. I can't tell if that's hot or just where I repaired it. Probably where I repaired it. I had some cracks in here, so I had to glue that back together. but it's pulling the air in here quite well, pushing it out here quite well. A lot of air movement. The challenge is getting the air from all over because I'm localized here. I'm just sucking it right out of this side, on this side. It's not exactly the best position to be in. I got my lights on, but they're just not well placed. Wait, I have a better light. Oh, I have my magic light. You'll like this. That ought to show it for you. So, maybe a little better. This is LED, but it's as good as I got. You can see the heat sinks on the transistors and the power coming out. Engines on the rollers. Oh, look, this coupler had been moved. Maybe I did that when I unplugged the thing. That's possible too. So now the thing you do when you do these, you got to assess everything. You know, you got to know that what happened, what got hot, where are we. The probes moved. Make a note, probes moved on me. Probably the vibration. They weren't really pinned down well, and that's probably what I'm going to have to do when I get ready to do this again, is to put them in a position so they stay put. I want to route them underneath here so I can put the lid on nice and tight, but I didn't get to that, so it's a semi not good test. We're cooling down. We're getting down to 48 and 30, 40, so they're coming to room temperature pretty readily. Oh boy, yeah, there's some heat buildup in the sides, a lot of heat buildup in the back. I know that, as you can see. If I hold this up, if I hold this over here, you can see it. Whoa! Yeah, it's supposed to be straight. That one's sort of straight. This one, not. You can see the ripple in it, right? So I'll reinforce that, make it thicker. That's the easy part. I guess I'll just think this through and get back to you with something later. But thought I'd let you know, see how it's going. It works. It does what it's supposed to. I don't have the trim to the voltage in the perfect way with that trim pot. That's kind of a energy waste. I'm making everybody hot just to do this. So I'll look at some other methods that I have, see what I can come up with. I'll post some more when I get it later.